Hello everyone. In this video, we will continue to work with integration of transcendental function, and we deal with definite integral in this case, so we have to apply the fundamental theorem of calculus. Alright, so in previous example, what we have done is we are trying to take a look at the integrand to see what type of substitution that we are going to use, or we just applied it straight from the formula sheet. We have to see a function raised to certain power, and we have to let that function equal to u, and then we differentiate u and then manipulate our ratio to figure out our differential factor. Then in one of the examples that we have done in previous video, I kind of give everyone a strategy. Okay, so what I have done is I told everyone that if you are having an e raised to an exponent, okay, so right here you have an e raised to exponent, then because in this integrand you have a function raised to a power, so you have no choice. You have to let that function equal to u. Okay, but you just have e raised to a power, then what you need to do is you need to let that u equal to the exponent of e. Then you can just apply these formulas. Alright, so in that case it will apply to our question number 10. So we have done quite a few example in the previous 3 videos. So this is video number 4. Okay, this is video number 4, and I will include the link for all the videos underneath, so you will have access to all 4 videos involving integration of transcendental function. So you see right here, if you just let u equal to sine of 2x, so differentiate this, you won't be able to get rid of the e with the dx. There's no way that you can match the differential factors. So therefore, whenever you see e raised to an exponent, so the best strategy is to let u equal to the exponent of e. So I'm going to let u equal to cos of 2x. Okay. Cos of 2x. So immediately after, I will take derivative of u. So when I take derivative of u in terms of x, then I need to review, right? So we go back to our formula sheet. So what is derivative of cos? Derivative of cos is negative sine. But I must multiply that by derivative of the argument itself. Okay, so therefore, when I take derivative of this, I should have negative sine of 2x that I multiply by derivative of the 2x, which is 2. So u equal to cos of 2x, therefore derivative of u du over dx will be equal to negative 2 times sine of 2x. So I will manipulate this ratio. So du divided by negative 2 will give me sine 2x dx. Because you can see that this is evaluate from 0 to pi over 2. I can write e to the exponent u. Okay, so let me rewrite everything so you can see that so cos 2x times sine of 2x times dx. Okay, so now you see that this already matched with this one. So let me put this in the cloud because I already complete my differentiation, and I found my differential factor. To replace this, I will write du over negative 2. So that will be integral from 0 to pi over 2 of e raised to exponent u times du divided by minus 2. Bring this constant across the integral sign, so I end up with just e to the exponent u du. And the integral of this is just exactly equal to itself again, right? So I will have negative a half e raised to the exponent u plus c. So now I'm going to replace this with the actual function u equal to cos of 2x. At the same time, I apply my fundamental theorem, evaluate the upper limit, subtract the function evaluated at the lower limit. So I will have negative a half, okay, e raised to the exponent cos of 2x, and this will be evaluated from 0 to pi over 2. So I will write this as the a half, okay? So this will be e to the exponent cos of 2 times x, that means times pi over 2. Subtract e raised to the exponent cos of 2 now times 0. Okay, so you see this is the f of pi over 2 and this is the f of 0. Okay, so let's see what I have. I am having it as negative half. And what is cos of 2 times pi over 2 should be e raised to the exponent cos of just pi. Right? Okay, so you can simplify this 2 times pi over 2, so it's just pi. And subtract e cos of 2 times 0, and it's a 0. Close that. So don't forget, cos of 0 is equal to 1. Okay, and cos of pi is equal to minus 1. So I should have this equal to negative half e raised to the exponent negative 1, subtract e raised to the exponent 1. Okay, so don't ignore this. Cos of 0 equal to 1. Cos of pi is equal to minus 1. So for this, you can simplify to have this as the exact expression, but I believe at the beginning of the example, I asked everyone if you can evaluate to 4 decimal places, okay? Or write it as 3 significant digits. So let's do that. So then what I have, if I will have negative half, okay? So what you want to do is you want to use your calculator and familiarize yourself with the e, the irrational number e. When you raise e to the exponent of minus 1, I will end up with this number. So I need you to use your calculator and also get this number to make sure that you know how to work with that function e. Alright? And what is e raised to exponent 1? It's just the irrational number e itself. Irrational number e is 2.71828. Okay? So this will give me negative half. And inside the bracket, I should have negative 2.3504028. Okay, so it's 367,879, 2.71828. And this subtract this to give me this number, negative 2.3504028. And I multiply this with negative half, I should have a positive result, which is 1.1752. Okay, 4 decimal places as required. Okay, so don't forget that this should be a positive values. So when you calculate the definite integral, is to calculate the area under that particular curve with the upper limit and the lower limit. So you present the area under the curve, so most of the time you should end up with a positive value. Okay, so let's see here if I have to express it at exact, then as exact, then is negative half and 1 over e, right? So let me rewrite everything. So what I have is I have e raised to the negative 1 subtract e. So then you should have it like this. So 1 over e subtract e. So negative half. This should be e squared, right? E squared. So that should be e. Subtract. No, not e squared. I'm sorry. That should be e. Because I will take the common denominator as e. So this will give me, if I do e squared, I have too many e's in this case. So this is the common denominator as e. So this would just be 1. And that should be e squared. Alright. So now multiply that into the bracket. And we have negative 1 times 1 times that. So 2 times e. So negative 1 times e squared. I should have positive e squared. And then negative 1, I should have that. And then divided by 2e. Okay, so let's see if it ends up to be the same number as 1.1752. So I'm going to get my calculator out and just give me a couple minutes. So not couple minutes, a few seconds. So I can double check my answer. Okay, so I should have e squared. So at the same time, I would like everyone to get your calculator and then work with this as well. Okay, so e squared, subtract 1, and then I divide that by 2 multiplied by the number e. Yeah, I have the same result, 1.1752. All right, okay, so 3 significant digits would be, just let me quickly review significant digits for everyone. So that means it will be 1.18, okay? Because 5 right here, you need to increase this one. All right. Okay, so let's see how many minutes that I have left. Okay, so I just have to click this. Okay, I do have time, so I will go over question number 11 as well. Okay, so this one, again, just a quick review. If you have e raised to a certain exponent, then the best strategy is to let that exponent equal to u. And then you differentiate, try to find differential factor. So you see that it's matching with this. Okay, then we go from there, apply fundamental theorem, and we should get the answer as required. So now going to this example. Okay, this example, what we have is, again, we need to apply, this is a definite integral, so we apply the fundamental theorem at the end. And what I have is I have cotangent. Okay, so you see, with cotangent, I strongly believe that we have a formula for cotangent. We have a formula for cotangent, integral of cotangent. We do have a straight formula for that. So therefore, in this case, you are going to let u equal to x to the exponent 4. Okay, so let me again show you the formula for cotangent. Okay, so cotangent, here is our formula to figure out cotangent right here. Integral of cotangent of u du will be equal to the natural logarithm of sine u in absolute values. All right, so in that case, what you need to do is your u will be equal to x to the exponent 4. Okay, so I'm going to let u equal to x to the exponent 4. So immediately after, I'm going to differentiate this. I will have 4x to the exponent 3. Okay, now you see there's an x to the exponent 3 right here. Do you see here? Okay, then what I will do is I will write du over 4 equal to x to the exponent 3 times dx. Okay, now, so what do we do here? I will write the -1 at the front, bring that across the integral sign, write cotangent of cosine. So cotangent, excuse me, cotangent of x raised to the exponent 4 multiplied by x to the exponent 3 dx. Okay, so this is your differential factor right here. N is equal to what you have done as you differentiate and then you manipulate your ratio. So now I'm going to substitute -1, 1 to 2, cotangent will be cotangent of u, right? And this will be written as du over 4. So bring the 1 over 4 across the integral sign. I will have -1 over 4, 1 or 2 cotangent of u du. Now apply formula to that. I should get this as a cotangent of u, so it will be ln absolute value of sine u plus c. Now substitute the x back in. So ln of sine of x raised to the exponent 4 absolute values, and I'm going to evaluate this, apply fundamental theorem from 1 to 2. So that means I will have the f2 subtract the f of 1. But in this case, what I will do is I will work like this, okay? So I will write it as -1/3 multiplied by this. Okay, so now I will have -1, I mean 1 over 4. I'm sorry, I don't know why I say -1/3. So -1 over 4. So like I mentioned to everyone, it's come with all age. So it's come with all age. So it's 1 over 4 negative. Okay, then I will write ln of absolute value of sine of 2 to the exponent 4. Okay, close the bracket, subtract ln of absolute value of sine of 1 raised to the exponent 4. Close this, everything multiplied by 1 over 4 as negative. Okay, so -1 over 4 times natural logarithm of this sine x, but x is now equal to 2, so I put 2 in here, so 2 raised to exponent 4. And then I subtract that with f of 1. That means I subtract with natural logarithm of sine of 1. Now x becomes 1, so 1 raised to exponent 4 as absolute value. Okay, so continue on. I should have negative this. Okay, so I should have ln of sine 16 so I better ln of sine 2 to the exponent 4 is 16, and 1 to the exponent 4 is just 1 again. Alright, okay, now I would like you to put your calculator in radian mode. Okay, okay, so we should work with radian mode. So I will put my calculator in radian mode. Okay, so we are going to do some calculation here. So first of all, you want to find sine of 16 first. Okay, so what is sine of 16? Sine of 16 in radian mode will be 0.28790. So I work with 5 decimal places. what is sine of 1 in radian mode? 0.84147. Okay, so use your calculator at the same time with me. Find the sine of 16 in radian mode. It will give you this number. Sine of 1 in radian mode will give you this number. And you know that this ln of this is already a positive value. Okay, so you need positive value to work with. But ln of less than 1 should be a negative value. Okay, so absolute values of this is already positive, but you take ln of this number, you should end up with a negative value. Okay, so this should give you negative 1.2451. Subtract, okay, ln of this should be a negative value as well. So it's negative 0.1726. Okay, so then I should have this equal to, don't forget, this will become plus 0.1726. Okay, so this will make it a negative value in this bracket. Multiplied by the negative value at the front, I should have it 0.2681. Okay, as 4 decimal places. So with 3 significant digits, so review our significant digit, then it should be equal to 0.268. Okay, so I really want everyone to make sure that you know how to work with your calculator in terms of ln, in terms of sine as radian. Okay, so let's review this question one more time. So this question, what you have to consider in this case, you have a cotangent. There's a straight formula for you to work with cotangent. So therefore, your u has to be the argument of this transcendental function, of this trigonometric function. So that will be cotan of u. Okay, the rest of this is to help you figure out the differential factor. So if u equal to x to the exponent 4, derivative of that will be 4x to the exponent 3. Manipulate this to get x to the exponent 3 times dx. In the way that you separation your variable in this case. Okay, so separating this, you see, is the exact match of x to the exponent 3 dx. Right here you have x to the exponent 3 dx. So instead of writing x to the exponent 3 dx, you are writing du over 4. So then you have the argument in terms of u. Your differential factor also is du. So you bring this constant across the integral sign, multiply by -1. You end up with these formulas. So you can apply that formulas. So integral of cotan of u will be equal to the natural logarithm of sine of u. Then you substitute u as x to the exponent 4 back in. Now apply our fundamental theorem of calculus. So that means you have to evaluate at the upper limit, subtract the evaluation at the lower limit. And we substitute it in, we have that. And because we are working with radian mode, 16 and 1 should be in radian mode, then you can find that as the values right here. And don't forget, ln of any number between 0 and 1, it will be a negative value. So this turns into a negative value. The absolute values here is applied for the sign. So absolute values of a positive number is also a positive number. But ln of this number turned out to be negative. Ln of this number turned out to be negative. Do our bad math, do it correctly, and then round to the correct significant digits or correct to the decimal place. Alright, so that's conclude all the videos for our strategy of integration or method of integration. So I have a couple minutes left. I want to conclude all 4 videos. Okay, so to conclude all 4 videos, I would like everyone to take a look at the formula sheet that I have given to everyone. Okay, so I am given everyone a derivative of transcendental function. Why do I give you this page along with the integration of transcendental function? Because if you are using the substitution method, this two sheet goes, they go hand in hand. Okay, one supports the other. So derivative support integration, integration supports derivative. So you should have these two sheets side by side. Okay, have these two sheets side by side. So it's easier for you to look for what formula that you need to use, and when you have to integrate, what formula you need to use, when you differentiate, what formula you must use. Okay, so these two sheets, you should have them side by side. And the next step is to remember the strategy of integration. Okay, so before I go to that, I would like everyone to remember that we have worked with the basic integration already, the rule for integration. Add 1 to the exponent divided by the result. We learn all about the properties. You can break them into individual integrals in terms of difference and sum. Okay, if the constant, then you put across the integral sign, and then you analyze your integrand accordingly. Okay, so you have a function raised to a power, the same basic rule apply here, but you have to match your function as u, and that's your du. Okay, so u du. So most of the time, if you apply these formulas, it will be you are using the substitution method. Okay, here it's just x and dx. You see that? U, then it has to be du. Okay, then if in terms of having like the exponent equal to -1, then you are falling into the special formulas, and in this case it will be equal to ln of absolute value of u. And definite integral, apply fundamental theorem, we've learned that already. And the last thing I would like everyone to pay attention to is the strategy of integration. Okay, strategy of integration. For this course I believe is 1436, or in future courses such as 1434, if you are taking integration, a course about integration, then you have already learned about derivative. Okay, then the very first thing you learn about integration is the basic rule of integration. After you master the basic rule of integration, you see that it's more challenging than the differentiation. So why is it challenging? It's challenging because you are starting integrating the transcendental function. If you integrate in transcendental function and any complicated integration, there's no fast rule for that. You cannot apply formulas at 1 to the exponent divided by the result right away. Okay, you don't usually see the integrand that's easy for you just to add 1 to exponent divided by the result. It's not like that. Okay, so if you encounter different type of integrands and you just have no idea what to do, then I would like you to refer to that two formula sheet first. Okay, but you still cannot see a straight formula from there, then you need to simplify the integrand if possible. When you simplify the integrand, you see that you use algebraic manipulation, you break into two fractions, or you use trig identities, you use property of logarithm, and you look for the obvious substitution. Okay, so then in those 11 examples that I went over for 4 videos, I try all the different type of integrand for you to look for the u. Where do you have to find the u? If I let u equal to and I differentiate that u, what does that help me? Okay, so because the step next to the differentiation is to manipulate that ratio so that you can match, and then you can replace your integrand with x by u. But you have to replace logically, right? So how do you do that logically? Is to manipulate your ratio accordingly. Okay, so there's a lot more to integration, but for this class I think we just stop by 3a. Alright, thank you everyone.